One, start.
Okay. Good morning. Welcome to online classes TRA Society. Students, today we are going to see second chapter in physics, that is ray optics on spherical mirrors. Let us say this is related to light. What is light and how does it originated, from where it is originated, and how does it travel? These are we have to discuss simply in the introduction part. Actually, all of you know light is a form of energy which gives us sensation of sight to our eyes. We can see all the objects not only having eyes, there should be a help of light. When light is falling on some bodies, which are we call it as all the bodies are divided into two parts, luminous and non-luminous bodies. When light is transmitted from originated from luminous bodies, the source of light is luminous bodies like sun, stars, and glowing candle, electric bulbs. These are all source of light. So when light is originated from these illuminous bodies and falling on non-luminous bodies, then they scatter in all directions. These scattered light enters into our eyes and we can get the sensation of objects. We can see all the objects. So the light originated from its source and travel with most important property of this light is enormous speed without any medium. Light from, if the in general in daytime, we can get light from sun. So what is the medium between earth and sun? Means space only, no medium. Even though there is no medium, we can experience the heat and light of sun rays. Therefore, light travel with high speed. That is, the velocity of light is also calculated by scientists as 3 into 10 power 8 meter per second. It travels in straight lines. Another important thing, there are two important properties of light. Without any experiments, you can tell, that is its speed. And second one is light travels in straight lines. How you can tell light travel in straight lines means if you are take a torchlight and put your hand, you can see the shadow of your hand and fingers. What does it mean? Shadows are forming means light does not travel through your hands. It is always travel in straight lines. So by this simple experiments, you can tell light travel in straight lines. Therefore, whenever the path of the light is considered, we have taken as a ray, a straight line. That's why the name of the chapter here, this is we are telling it is ray optics. Optics means study of light and the nature of this light, how does it travel, what are the properties. In this chapter, we will see spherical mirrors. Those are devices, spherical mirrors. And also, whenever we are using a mirror, it has some parameters, some important points in these mirrors, and also a mirror equation. And whenever you are using the magnification and the properties of reflection and refraction, and refractive index of prism and total internal reflection, this type of some short notes we will see in this chapter. Now let us see what are spherical mirrors. When any mirror is taken from a part of a spherical glass, if you cut a glass of spherical glass, then you can get two halves. When you are taking the one side, you have to take in a polish, then it will seem as concave mirror, and opposite side you are polishing, that is called convex mirror. So both these two can be formed for a spherical glass only by polishing side is changing. The hollow is considered and polishing change is changing. Two sides are there. One is hollow spherical glass, you observe. There are two sides. When you cut it half, what are the two? We call it as one is polished one, where in which side we are polished, and another one is reflecting surface, where in which side light will fall. The incident light is received by this reflecting surface. Let us see in this diagram, concave and convex mirrors. In this, you can understand at the center of this hollow glass that we call it as center of curvature. If it is a hollow sphere, if you are taking two parts, one side in the red color, you can say refracting surface this side, another side, actually that is polished. That is, we have taken a paint without entering the light. Only these mirrors makes the light reflect. You know what is a reflection and difference of refraction. Generally, reflect means in which direction the light is incident, in the same medium again it returns back. That is reflection. So all the mirrors forms the images by the property of reflection. You see concave mirror in the upper, in the down, reflective surface, convex mirror. Here you see convex mirror is upper side, as the bulbous side is a reflective surface, and back side we have to take polish, and both these two have center of curvature. Whenever you are using the mirrors, you have to know the primary knowledge about these mirrors. Just we have to understand some parameters of the mirrors. First parameter is its pole. What is the pole? This is generally the geometric center of mirror. The midpoint of the mirror, we call it is denoted by P. Geometric center of a mirror is pole of the mirror. And second, center of the curvature, just we have seen in the diagram, center of the spherical glass from which the mirror is taken. Mirror is considered, imagine a mirror is always a part of a sphere. The center of that sphere is called center of curvature. Okay, this is represented by C. The letters are also very important here we are showing. Whenever you are using the formula and equation, we will use these letters. That's why these are indicated in red color to identify you. Whenever we are using P, that is pole of the mirror. Whenever you are using C, that is center of curvature. And third one is focus point. Focus point means the parallel rays of incident after reflection passing through a point on principal axis. It is called focus point. Before going to see it, better to know what is principal axis. The principal axis means what we have discussed, pole and center of curvature. Joining these two, we can draw a line horizontally to this, that is called imaginary line passing through P and C, which we call it as principal axis. The line joining pole and center of curvature of any mirror is called principal axis. Now let us see what is focus point. Now a parallel ray means for what it has to be parallel to principal axis. It indicates when a incident ray, light ray is parallel to this principal axis, then after reflection, it cuts at a point on the principal axis. After reflection, it passes through a point. That point is called focus. Okay, can you understand? Now coming to focal length. Focal length means nothing but the distance between pole and focus point. This focus point to this pole of the mirror, how much distance it is? It is called focal length. That is generally represented by centimeters. And next, radius of curvature. This is also important one. The distance between 2 points, that is pole and center of curvature. You understand, if you know P and C, you can write two definitions. The distance between P and C is called center of curvature. How much curvature it is? So center of curvature is distance of P and C. If the line joining P and C, imaginary line, is called principal axis. Okay, don't confuse. That is the only line. Principal axis means the imaginary line. In general, while drawing ray diagrams, we have to take, this is a reference line. Whenever object is placed, where you have to place the object means on the principal axis. So these are the important parameters of any mirror, whether it is concave mirror or convex mirror. There should be a pole, which is geometric center, and also center of curvature, which is the center of the sphere from which the mirror is taken, and focus point, the parallel ray falling on the mirror after reflection takes place from a point on the principal axis, that is focus, and the axis or imaginary line joining P and C, principal axis, and focal length means distance between focus point and pole, and radius of curvature means pole and center of curvature distance. So always focal length and radius of curvature should be measured from P, pole of the mirror. These are the important parameters before going to see. Next, while using any derivation formula, we have to use some sign convention. That is also important. What is the sign convention? Generally, we have to adopt one method. In graph, we can take, this is x-axis, this is y-axis. Right side, we have to write x positive, left side, x negative. Similarly, vertically, y-axis is positive upwards, downward negative. This is a convention. At the center, we are writing as origin in the graph, 0, 0 point. Similarly, while we are using any mirror, we have to use some sign conventions. While otherwise, you can't understand where we have taken the object, where you are placing the mirror. All these we cannot understand. That's why first one is all the distances should be measured from pole of the mirror. We have already discussed what is the pole. That is the geometric center of the mirror. All the distances should be measured from P. And the another thing is objects is always placed to the left of the mirror. While you are drawing the ray diagram, how the image is formed. In your 10th class, we can see different objects while they are forming at P, between P and F, above the P, like that. In different positions, we can place the object before the mirror. Where the image is formed, we can see. While you are taking this, object is always placed to the left of the mirror, whether it is concave or convex. Now, second one is all the distance measured along incident ray. Distances we have to measure. Object is placed. Generally, we can measure the distance from object to mirror or mirror to object. The length is constant. There is no problem. But here, according to sign convention, if you are measuring the distance along the incident ray, we have to take as positive. Opposite to that, if you are measuring the distance opposite to incident ray, it should be considered a negative. So first one is distance should be taken from P, and second sign convention is how the distances are taken as positive or negative. Okay, and third one is, okay, you are placing the object, then what happens? The image is formed. Sometimes, according to ray diagrams and position of the object, you can see the image may be formed above the principal axis or below the principal axis. Okay, then that's why height of the object, whether height of the object or height of the image, how to measure, that is related to third sign convention. The heights measured above the principal axis are taken as positive, and the heights measured below the principal axis should be taken as negative. Just like in y-axis, above positive and below y-axis, how you can take the values, positive values above, or below y-axis we have taken negative. In a similar way, if the heights we have to measure below the principal axis should be considered as negative. So these are sign convention. First, we have to know some parameters of mirrors, and next we have learned about sign convention while using these. Now let us see focus of concave and convex mirrors, how they represented in these diagrams. You can understand there are two, both I am showing you. Concave mirror, first you see parallel rays while incident on this concave shaped one reflecting surface, then the reflected rays passes the F. The middle line that is dotted line, which it is written as principal axis. So the rays parallel to principal axis after reflection passes through one point, that is focus. How to show focus here? Now coming to convex mirror, actually the rays are showing here. The parallel rays are not passes through F after reflection, but seems to be passed. F is right side of it, as it is convex. You have to show F here, that focus point. So dotted lines are shown. Dotted lines indicate we have to produce those two reflected rays and seems to be passed from focus point. That is focal length, F. Generally, focal length is represented by small f. If the focus point, if it is a point, we have to represent capital letter, capital F. Capital F represent focus, small f represent focal length, the length we want to measure. So this is just to understand how to draw the ray diagrams to show the focus. Now let us see relation between radius of curvature and focal length. This is also we have shown for concave mirror. We have taken here a concave mirror right side, and here P is the pole of this concave mirror. These lines, that is polished one, is represented by lines, and CP line, that is principal axis, and only a single ray we have taken to understand the relation in this derivation. The parallel incident ray is shown. This parallel ray is falling at Q, strike the point Q and passes through F. Whenever a parallel ray, immediately it has to pass through the focus of the mirror, as we have discussed earlier. So here the important thing is, whenever a ray is falling like this, you can see C on Q dotted line. Actual ray is falling at Q and reflected in the direction of QF, as shown in the arrow mark. Don't forget to put the arrow mark, as it is a light ray. Ray is shown with arrow mark, not just lines. This is light ray. So you must and should show the arrow mark. Now, whenever there is a reflection takes place, in plane reflection, we are having two important rules or laws. What are laws of reflection? First one is angle of incident is equal to angle of reflection. That is, whenever reflection takes place on plane mirror or wherever a reflection is observed, immediately the first law is angle I is equal to angle R. That means incident angle and reflected angle should be equal. And second one is these two rays, reflected ray, incident ray, and the normal at the point of incident. We have to draw a normal at the point of incident. All these three lie on a same plane. These are the general laws of reflection. So here you can see incident ray and reflected ray. Where is the normal? Whenever you are joining the C to that point of incident, it always normal. Remember, wherever the ray fall on the reflected surface of mirror, at that point, here the point of incident is Q. From this Q point, you join C. You have to join C. That is, automatically it is 90 degrees, where you can draw a tangent line at Q to this curved surface of concave mirror. So it is called normal. CQ is the normal. So according to the laws of reflection, this angle Q is divided into two. Above, opposite to this normal theta, and there is also theta. Normal both sides you can see angle of incident and angle of reflection. According to the rule, always both these two are opposite to the normal. So both these two are equal according to laws of reflection. Therefore, angle CQF is also theta. Now, when these two are theta, incident angle theta and reflected angle is also theta, then angle QFP becomes 2 theta. Theta plus theta is this angle. Why? Because this incident line and CFP, both these two are parallel, and QF is transverse line. So whenever there are two lines, one transverse intersected, these are alternate angles should be equal. Therefore, that is theta plus theta above 2 theta, and therefore angle QFP also 2 theta. This is about the diagram. Now let us see the derivation in this triangle QCP dash. You see in this triangle QCP dash, you have joined Q and a perpendicular line, which is, we call it as P dash. This is just, we have to construct a perpendicular line. What is the construction here? We have to draw in CQ line and QP dash, a perpendicular line to this principal axis. Therefore, you can see two triangles with theta and 2 theta. Those two I am writing QCP dash and QCP P dash. This, in this angle QCP is theta. QCP dash. Then in this triangle, tan theta QP dash by CP dash, opposite by adjacent I am writing. That is equation 1. And in triangle QFP dash, QFP dash, this is another triangle. In this tan 2 theta, this is also right angle triangle. Tan 2 theta is equal to QP dash by FP dash. This is second equation. For smaller values of theta, if it is very small, theta is very small, radius of curvature is very less, then theta is very small. This is a special approximation we have to take here. When it is small, which is true for paraxial rays, parallel rays are, we have considered approximately tan theta should be theta, and you cannot write tan 2 theta, just you write 2 theta. Tan theta is theta, tan 2 theta is equal to only 2 theta. So equating 1 and 2 equations, again you can write theta is equal to QP dash by CP dash, and 2 theta is equal to QP dash by FP dash. Now 2 theta is QP dash by FP dash, therefore you substitute theta value here. So 2 into QP dash by CP, which is equal to QP dash by FP dash. Okay, so then 2 FP dash, while QP dash and QP dash cancel out. So only remaining cross multiplying 2 FP dash is equal to CP dash. So FP dash 2 is equal to CP dash is derived. But here in the diagram also you can understand P dash is very close to P. And this is also another approximation. We have taken two approximations. One is theta is very small, and next approximation is if P dash is very close to P, instead of FP dash, you can take FP. Similarly, instead of CP dash, we can take CP. So substituting those values, FP becomes pole to focus point, that's why it is focal length F, and CP pole to center of curvature distance, which is equal to R. Therefore, 2F is equal to R, or F is equal to R by 2. So this is the relation between all these two, focal length and radius of curvature. So this is also one important derivation we have to ask in the examination. Even though it is very simple, we have to take two triangles. Whenever the derivations in this mirrors, remember, always we have to take two triangles. Always we will take triangles. Why? Because there are parallel lines and perpendicular lines. That is also right angle triangles are considered. So based on that, some ratios we will compare, and similar triangles sometimes we can take. Comparing the similar triangles, we can derive that derivation. That's why which triangle we have to take. Once you practice drawing the diagram, ray diagram is very, very important. Without this diagram, you cannot write all these QCP dash, Q angle QCP, tan theta. How you can write all this? Without diagram, it is very difficult. So children, carefully practice first ray diagram. Whatever the derivation it is, first you draw the diagram clearly. The letters may be changed. C, P, F are constants. Sometimes you can write A and B. In place of Q, you can write A. And similarly, in place of P dash, you can use another letter. No problem. But don't change F, P, C. Why? Because these are conventions which we have followed. As the parameters indicate, F is focus, C is center of curvature, P is pole. So you don't change these three. Remaining you can change, and values, how the triangles are formed, understand. This is about relation between radius of curvature and focal length. Okay. So students, what we have learned today: what is light, how the light is originated, how does it travel, and what are the properties, and what is a mirror, and what are the spherical mirrors, and the types of spherical mirrors, concave and convex, and some important parameters of mirrors: pole, focus, center of curvature, and also principal axis. And we have learned about focal length of a mirror and radius of curvature of a mirror. And next, after that, we have seen focus, how to show focus in case of a concave mirror or convex mirror. Both these two we have to practice. In the examinations, in short answer questions, the diagrams are also very important. To show the ray diagram to the focus when the parallel beam of light is incident on convex mirror, they don't ask to show the focus. The question is like this: what is the, when the parallel ray of light is falling on a convex mirror, show the ray diagram. That's all. So you have to understand the question is, when parallel beam of light is incident on a convex, it has to pass after reflection. These rays has to fall through focus point. So you have to, it seems to be focus point. Actually, if it is a convex mirror, it seems to be passed through focus point. Otherwise, in concave mirror, directly the reflected rays passes through focus point. You should remember. And lastly, we have discussed about relation between radius of curvature and focal length. While deriving this small derivation, we have to take a concave mirror. You can take convex mirror also, practice yourself. Instead of concave mirror, you take convex mirror, and just angles and letters are all same. The remaining derivation is same. There you can show two triangles as shown in this concave. You can prove that 2f is equal to r, or f is equal to r by 2. In this triangle, while drawing this, you have to practice ray diagram, and from this ray diagram, you take tan theta values. 2 times you have to tan theta and tan 2 theta. How it is 2 theta? That you have to write first. Whenever you draw the ray diagram, you have to explain in one paragraph. What is that paragraph? Let us consider a concave mirror is taken, and a parallel beam of light is incident at Q point, and the reflected ray is QF. The normal at the point of incident Q is CQ. Now, according to laws of reflection, the angle of incident, angle CQ or A letter you can write, that is theta, and reflected angle is CQF, that is also theta. Both these two are equal. Therefore, this incident ray and principal axis are parallel. Therefore, angle QFP is also 2 theta. First, you have to write the description in one paragraph according to the rays you have to draw. You have to write those. After that, the derivation. What is the derivation starts in this? There are two triangles, QCP dash, and also another one QFP dash. You have to take two triangles. These two right angle triangles, both we have to take tan theta and also tan 2 theta, two equations. And assumption is theta should be small. If theta should be small, instead of tan theta, you can take theta. Instead of tan 2 theta, you can take only 2 theta. There, theta is equal to what we are writing, QP dash by CP dash, and 2 theta is QP dash by FP dash is taken. And in place of theta, you substitute that qp dash by cp dash. Qp dash both sides cancel out. So 2 fp dash is equal to cp dash. And finally, what you have to do? Assumption, another assumption here you have to bring. P dash is very close to P. Instead of fp dash, you can take fp. Instead of cp dash, you take cp. So substituting these two, we can get 2f is equal to r. 2 into focal length is equal to radius of curvature. Therefore, this can be applicable to not only this concave mirror, it can be applicable for convex mirror also. So this is today's lesson. Tomorrow we can see mirror equation. That is most important one. And based on tomorrow we can say mirror equation and magnifications and some problems based on mirror equation and magnification problems. Okay, children. Goodbye. Thank you. This is the end of the lesson. Today's lesson.
Thank you, Sharma sir.
Thank you, madam.